Welcome back to Brainwaves. In today's episode, we will explore the fascinating world of snow. Snow is a beautiful and unique form of precipitation that many of us eagerly await during the winter months. Its delicate crystals and glistening landscapes capture our imagination. Have you ever wondered how snow forms and why it looks the way it does? Stick around as we uncover the secrets of snowflakes and learn interesting facts about snow. Let's dive right in. When it comes to the formation of snow, it all begins in the atmosphere. Snow is created when water vapor in the air freezes into ice crystals or snowflakes. But how does this process happen? It starts with cold temperatures, usually below freezing point, which causes the water droplets in the air to freeze. These frozen droplets then join together, forming intricate ice crystals or snowflakes. This mesmerizing transformation is influenced by factors such as temperature, humidity, and the presence of ice nuclei. As these snowflakes grow and become heavier, they eventually fall to the ground, creating the magical phenomenon we know as snowfall. No two snowflakes are exactly alike, and each snowflake boasts its own unique characteristics. Snowflakes come in a variety of intricate shapes and sizes, making them endlessly fascinating. Some snowflakes take on the classic hexagonal shape, while others form as thin, needle-like structures called dendrites. There are also snowflakes that resemble columns or plates. The intricate patterns and delicate structures of snowflakes are a result of various factors such as temperature, humidity, and the path they take as they fall through the atmosphere. The beauty of snowflakes lies in their individuality and the mesmerizing designs they create when millions of them come together to blanket the ground in a winter wonderland. Snow plays a vital role in the environment, beyond its aesthetic appeal. One of its important functions is providing insulation during the cold winter months. When snow covers the ground, it acts as a protective layer for plants, animals, and even insects, shielding them from freezing temperatures. Additionally, snow contributes to the replenishment of freshwater resources. As snow melts during the spring, it gradually releases water into rivers, lakes, and groundwater, ensuring a sustained water supply for ecosystems and human consumption. Furthermore, the reflective nature of snow helps to regulate Earth's climate by bouncing sunlight back into space, maintaining a balanced temperature. The importance of snow reaches far beyond its visual charm, making it an essential component of our natural world. To understand how snow forms, we need to consider the temperature requirements. Snow forms when the temperature in the atmosphere is below freezing point, which is 0 degrees Celsius or 32 degrees Fahrenheit. When the temperature drops below freezing, the water vapor in the air begins to turn into ice instead of staying in its gaseous form. This freezing process creates tiny ice crystals or snowflakes that are light and delicate. The colder the temperature, the more intricate and unique the snowflakes tend to be. So, the next time you see snowfall, remember that it is the result of the perfect combination of temperature and atmospheric conditions. In addition to the temperature requirements, another important factor for snow formation is the presence of moisture in the air. Snow forms when there is enough moisture or water vapor present in the atmosphere for it to freeze and crystallize. This moisture can come from various sources such as evaporation from bodies of water, including lakes, rivers, and oceans. It can also come from moisture released by plants through a process called transpiration. When the air becomes saturated with this moisture and the temperature drops below freezing, the water vapor begins to condense and take the form of ice crystals or snowflakes. Therefore, the combination of chilly temperatures and sufficient moisture is what creates the magical phenomenon of snowfall. Now, let's delve into the fascinating freezing process that leads to the formation of snow. When the temperature in the atmosphere drops below freezing, the moisture or water vapor in the air begins to transform into ice. This process is known as crystallization, where the water molecules rearrange themselves into a solid structure. As the temperature continues to decrease, these tiny ice crystals further develop into intricate snowflakes. The exact shape and structure of the snowflake depend on the conditions of the atmosphere, such as humidity and the presence of ice nuclei that act as a catalyst for crystal growth. The freezing process is a captivating transformation that turns ordinary moisture into the extraordinary beauty of snowflakes we admire. Welcome to the fascinating world of snowflake shapes. Snowflakes are incredibly diverse, and each one carries its own unique beauty. No two snowflakes are exactly alike, making them like nature's individual masterpieces. There are three main types of snowflake shapes that we commonly encounter: dendrites, hexagons, and columns. These shapes are determined by the conditions in which the snowflake forms, including temperature, humidity, and atmospheric pressure. Let's explore each of these types and marvel at the incredible intricacy and diversity of snowflakes. Dendrites are one of the most intricate and captivating snowflake structures that we observe. These snowflakes form under specific conditions in which the air is moist and the temperature is close to freezing. Dendritic snowflakes have a beautiful, branching pattern resembling delicate ice ferns or frost on a windowpane. Each branch of a dendrite can have even smaller branches growing from it, creating a mesmerizing display of complexity. The branching structure of dendritic snowflakes is a result of the growth of ice crystals in different directions, forming an interconnected network. The intricate beauty of dendrites leaves us in awe of nature's craftsmanship. Hexagons are one of the classic and recognizable snowflake shapes that often come to mind when we think of snow. These snowflakes are formed in conditions where the air is slightly warmer and not as damp as when dendrites form. The six-sided shape of hexagonal snowflakes is a result of the hexagonal arrangement of water molecules within the ice crystals. The unique structure of hexagons allows them to interlock and tessellate, creating a stunning geometric pattern. These symmetrical and uniform snowflakes showcase the precision of nature's craftsmanship, and their repetition in billions during snowfall adds to the spectacular beauty of a winter wonderland. Columns are another intriguing type of snowflake shape that can be observed during snowfall. These snowflakes are typically long and thin, resembling tiny rods or needles falling from the sky. Columns often form when the temperature is very cold and the moisture content in the air is low. The elongated shape of columns is a result of the ice crystals growing in a vertical direction, creating a cylindrical or rod-like structure. Sometimes, columns can have flat or plate-like ends, adding a touch of variety to their shape. Despite their simplicity compared to other snowflake shapes, columns contribute to the overall beauty of a snowy landscape and remind us of the diverse forms that snow can take. Snowfall measurement is a crucial aspect of understanding and monitoring the amount of snow that accumulates during a snowfall event. By quantifying the depth of snow, we can better assess its impact on various aspects of our lives, such as transportation, agriculture, and even recreational activities. Snowfall is typically measured in inches or centimeters, depending on the region and convention used. These units allow for easy comparison and communication of snowfall amounts across different locations. Snow measurements provide valuable data for climate records, weather forecasting, and water resource management. Let's explore how snowfall is measured and the tools used to obtain accurate measurements. When it comes to measuring snowfall, two commonly used units are inches and centimeters. These units provide a standardized way of quantifying the depth of accumulated snow. In the United States, snowfall is typically reported in inches, while in many other countries, including most of Europe, the metric system is used, and snowfall is measured in centimeters. Both units allow for precise and consistent measurement across different locations. Snowfall depth is usually measured at regular intervals during a snow event or after the snowfall has ended. Understanding the units of measurement is important for accurate reporting and analysis of snowfall data. To measure the depth of accumulated snow, a device called a snow gauge or a ruler is used. A snow gauge is specifically designed for this purpose and consists of a long cylindrical tube with markings indicating the height of the snow. The tube is inserted vertically into the snowpack, and the depth of the snow is read from the markings on the gauge. Snow gauges are commonly used by meteorologists, weather observers, and snow enthusiasts to obtain accurate snowfall measurements. If a snow gauge is not available, a ruler can also be used to measure the snow depth. By carefully inserting the ruler into the snowpack, the depth can be determined by reading the markings on the ruler. It's important to note that when measuring, multiple locations should be sampled to account for any variations in snow accumulation. Using a snow gauge or ruler allows for consistent and standardized measurements of snowfall. Welcome to this segment on fun facts about snow. Snow is not just a captivating natural phenomenon, it also plays a significant role in the environment. Beyond its beauty, snow has important functions that impact both plant and animal life. During the cold winter months, snow provides insulation for plants, acting as a protective blanket that helps them survive freezing temperatures. Snow also serves as a natural insulator for animals, creating a cozy habitat beneath its cold surface where they can seek shelter and find food. In addition to its role in providing insulation, when snow melts, it contributes to the replenishment of freshwater resources. As the snow melts, it seeps into the soil, refills rivers and lakes, and eventually becomes a vital source of freshwater for ecosystems, agriculture, and our daily needs. So, let's dive into these fascinating aspects of snow and explore its significance in our environment. Snow plays a crucial role in providing insulation to both plants and animals during the cold winter months. For plants, snow acts as a protective layer, shielding them from the harsh elements. When a thick layer of snow covers the ground, it acts as an insulating barrier that helps to regulate soil temperature and prevent the plant's roots from freezing. This protection allows plants to conserve energy and nutrients, ensuring their survival until spring arrives. Similarly, for animals, snow provides a cozy shelter and insulation against the cold. Many animals, such as hibernating mammals or burrowing creatures, take advantage of the insulating properties of snow by creating cozy dens or tunnels beneath the snowpack. This provides them with a stable microclimate where they can hibernate, rest, or seek refuge from frigid temperatures. The insulation provided by snow is a remarkable adaptation that allows plants and animals to withstand the challenges of winter. When snow melts, it plays a vital role in replenishing freshwater resources. Snow is essentially frozen water, and as it melts, it gradually releases its water content into the surrounding environment. This process is important for maintaining the water cycle and ensuring a steady supply of freshwater. As the snow melts, the water seeps into the soil, recharging groundwater aquifers that serve as important sources of drinking water. The water from melting snow also contributes to the flow of rivers, lakes, and streams, which are essential for supporting various ecosystems and providing habitat for aquatic life. Additionally, snowmelt water is crucial for agricultural needs, irrigation, and the overall health of our ecosystems. The gradual release of water from melting snow helps to sustain water availability during drier months and is an important factor in maintaining the harmony of our planet's delicate water balance. And that brings us to the end of our exploration of snow. We hope you've enjoyed this journey into the fascinating world of snowflakes and snowfall. Remember, snow is not just a beautiful spectacle, it also plays a vital role in the environment. From providing insulation to plants and animals during winter to replenishing our freshwater resources, snow is truly remarkable. So the next time you see snowflakes falling from the sky, take a moment to appreciate the intricate designs and the magic they bring. Thank you for joining us today on Brainwaves. Stay curious and keep exploring.